There. All right. Good morning and good afternoon, everyone. Oops, I need to fix that. The camera's a little, there we go, a little crooked. All right. My name is Jillian. I'm the founder of Sharks4Kids, and I'm really excited to be back at the Sharklab for a special shark science hangout. We are on an island called Bimini in the Bahamas, and the Sharklab has been here since 1990. Started as a, oh, and that's Sasha, our dog friend. She wants to join. And it's been a base for doctors' lemon shark research, because you find lemon sharks from birth all the way to adulthood here. So it's an ideal spot for studying them. So I'm going to go ahead and let the team introduce themselves, and then we'll meet our classrooms and our special guest.
Hi guys, I'm Angela. I'm one of the lab managers, and I'm responsible for making sure everything runs smoothly here.
Hi guys, my name is Jessie. I'm the outreach coordinator at the Bimini Sharklab, and my job here is basically to be involved with the community, to aid with education, and to also lead some of the opportunities offered at the Bimini Sharklab.
Hi guys, my name is Dan. I'm a volunteer here at the Sharklab. My job is basically to assist both the staff and students in their day-to-day work.
All right, so we're going to introduce our classrooms. When you guys hear your class, please unmute your microphones and give a big welcome to everybody who's watching. All right, first off, we have Miss Dolat's class, grade 1 students in Michigan. If you want to go ahead and say hello. Hello. Thank you so much for joining us.
Thanks for having us.
Yeah. And then we have Miss Care's class from Austin, Texas. Miss Care, do you guys want to say hello? I'm not sure if they're hearing us. And then we also have Miss Farnell and Miss Triggs, students from St. James Primary in England. You guys want to say hello?
Ready?
Hi! Great. Welcome. All right. So along with our classrooms joining us, the team here and people watching, we do have a special guest. So today we are going to talk a little bit about shark science, how we actually study these animals, the equipment we use, and why we do it. So to help us with that today, hang on. I'm going to need the All right, hang on just a second. All right, you're all right. Can I just bring the camera? Yep. All right, so we do have a nurse shark. All right, and she's maybe a little camera shy this morning. All right, if you notice, she looks quite a bit different than what you might think a shark should look like or what you've seen. So we're going to go through, we're going to talk a little bit about her specific anatomy, the things that are kind of different from other sharks. She's still definitely a shark, but you've probably already observed some differences in the way she looks, how that helps her move, the habitat she hangs out with. Then we're going to talk about some of the equipment that we use when we're tagging sharks, so what that means. And then we're going to do a workup. So a workup is the way scientists collect data or information about sharks. Once they're caught, you can think of it like going to the doctor and getting a physical or a checkup. So it's like we're doing a physical for the shark to learn a little bit more about her. So we're going to go through each of those things, and then we will go ahead and do some questions. So we're going to get started with anatomy of this very cool species of shark.
Hi guys. So I'm just going to go through a quick lesson of anatomy, of nurse shark anatomy. I'm just going to grab this little girl very gently. And first, I'm going to show you, have you got the camera? First of all, I will show you its mouth. So you can see here that these little protrusions here, they're called barbels. And they use them to feel out their food. And they, can you see its mouth? It has a very tiny mouth and a very kind of flat, crushing teeth, very similar to the ones that you have in the back of your mouth. And that's because, that's because it eats things like crustaceans, like corn, crabs, lobsters. so it needs some really flat, crushing teeth to be able to cut through the shells. Which is not the same as like great whites who have them really pointy teeth because they eat different foods like marine mammals, so they need to shear through the skin. This little girl just needs the flat ones just to cut through the shells. And I'm going to show you here. I don't know if you can see, but they have very tiny little paws called Ampullae of Lorenzini, and they're around the snout. Can you see? And they use these for homing in on their food. Basically, these little paws have jelly in them, and it's called, and these little paws of jelly can detect the heartbeat of animals in the ocean floor. So even when their food is hiding behind rocks, which they normally do, they can detect their food through this heartbeat and this electromagnetic sense. But let me just grab the shark again. I'm going to show you her eyes. They're colored white. Now this means that they're most likely more active at night, and this little girl is. She's a nocturnal feeder. So she will rest under the rocks, which is where she lives in the day, and then at night she'll go hunting for her food. Here you can see the gills. This is how sharks breathe. You can only see 4, but they actually have 5 gills, and the 5th one is hid behind here. All sharks have 5 to 7 gills, and they use this for breathing. They're a little bit different. We have lungs, they have gills, and they use their gills. They pass water over their gills, and they extract the oxygen from the water, and this helps them breathe. Some sharks have to continuously swim through the water to be able to breathe, but this little girl, as with all nurse sharks, can actually lay on the bottom and just use special muscles in her mouth to suck in the water and take out the oxygen. So she's completely fine being the lazy shark that she is. They're actually known as couch potatoes of the ocean. All sharks have fins. These are pectoral fins. This is a dorsal fin, pelvic, anal, and caudal fin. So the caudal fin is the tail. And with fast swimming sharks like white sharks, mako sharks, they have an upper tail and a lower tail. And this little girl only needs the upper tail because she doesn't swim through the water. That second bit of the tail aids propulsion through the water. So that means that the sharks with the 2 bits of their tail can swim really fast because she's very lazy and lives under rocks. She doesn't need to move very fast, so she doesn't need the second bit to her tail. I don't know if you can you get a bit closer and show the skin? Sharks have something called dermal denticles, which means skin teeth. And these dermal denticles lay next to each other and form a kind of armor. So it protects the shark from predators. But also they can reduce the drag of the water so that they can move very fast through the water. Some sharks have these dermal denticles with a lot of ridges in because it helps them swim really fast. Now, as I said again, because the nurse shark doesn't move very fast, she doesn't need so many of these dermal denticles, so she has very large ones with very few ridges because she's lazy. Now, we know she's a girl because if we lift her up, these are her pelvic fins. And she has like a small hole with no other added bits to it. Now, if it was a boy, it would have the hole, but then it would have 2 pointy bits like this that we call claspers, and that's how we can tell the difference between male and female. Okay, that's it from me, and now Jillian's going to talk about tagging.
All right. So you guys can see she's still a shark, but definitely has some unique characteristics. There are over 500 different species of sharks, so they definitely have different kind of shapes, sizes, and adaptations to help them survive in specific habitats. Right now, you're going to see the data collection process in a minute, but part of that is tagging a shark. And you can think of the tags as a name tag. Scientists all over the world catch thousands of sharks, studying them for various projects, and we can't remember all of them, right? So even though some of them have unique markings, we really want to give them a name tag, but it's not actually a name tag, it's really a number tag. And there are a few different tags that we'll use. So here at the lab, every shark that is caught gets a pit tag. And you may have heard of these before if you have a cat or a dog at home that's microchipped. Right, so if your pet gets lost, it's got a little chip inside of it that the vet or the Humane Society, right? You can see it's really, really tiny. Let me back up a little bit so it can, and that goes just under the dorsal fin of the shark, and it's kind of like getting a shot or injection at the doctor's office. We use this scanner. So when the shark is caught, right, wave over it, all right? And if it has a number like this, oops. Right, you can see the number. That's the tag number. So we'll write that down in our data book. We don't have to memorize it because it's a really long number. And we're not trying to find lost sharks and return them to their owners. We're just trying to have sort of an individual identification for each animal. Right? If you go to the store and your item, the register kind of scans it and a price comes up, this is sort of like a barcode for the sharks, right? But they don't have a price. It's just simply their identification, their name. Another tag that's used here in Bimini and other places throughout the world, this is a Casey tag or a dart tag because it's got an actual dart that goes just under the skin of the shark. And you can see here we take the paper off after we write all our data down, and there's the number. So we either have to catch the shark again or see it again to remeasure it or see if it's in a new location. Or we can hope that maybe if a fisherman or someone catches the shark, they might let it go because they'll realize it's part of a study. This tag and the pit tag, you definitely have to either have access to the shark again or see it again to take some new measurements or learn something about that specific animal. Now, when you think about technology, phones have changed. They don't just make calls anymore or text, right? You can play video games, you can film a video, you can get directions. Technology is really incredible and it's letting us do a lot, and it's also changing the way we can study animals. So this tag is an acoustic tag, means it makes a noise. You can think of each tag kind of as having its own ringtone, but it's really a series of beeps. This can go on the outside of the shark or inside. If we flip a shark over, they go into a sleep-like state called tonic immobility, and scientists can actually perform surgery on the shark. They've got kind of this cavity right here with no vital organs, so you can make an incision, slide this tag in, stitch it up, flip the shark over, swims on its way, has no idea what's happened. It's kind of like anesthesia that people get, or your pet might get if they've had surgery. So it's a natural anesthesia for the shark, so we can put this tag in. The shark can't hear the tag, we can't hear it. There are special receivers or listening devices that can be placed on the bottom, or we can hold them and track the shark that listen specifically for these tags. They help us figure out which sharks are in the area, how often they come to that spot, because the receiver will record the tag number, the time of day, the date, and the water temperature. Right? And this is kind of how we also know which sharks are hanging out with each other. Yes, some sharks have friends, right? Some are very social, like the little lemon sharks we have here that hang out in the mangroves. And this is part of the reason we actually know that they're hanging out with their best buddies. We're seeing how much time they're spending together. And the last tag is really amazing technology, right? So this is pretty much like strapping an iPhone to a shark, but obviously we couldn't do that. So this is our version. Just like a phone, you can get directions or it shows you where you are, or GPS in the car. Believe it or not, there's a mini computer inside there and batteries that charge that computer. So on the fin are at least a 3-meter tiger shark, mako shark, great white, a species that spends time up near the surface. So that dorsal fin sticks out of the water. There's a little sensor right there that when it feels the air, it transmits a location up to a satellite, and our shark sends us an email. You might be thinking, wait a minute, shark email? They're not crafting us nice notes. The tag's doing all the work. It does show us where they are, where they're going, and helps us answer questions like, why are they migrating so far? Why are they going to that habitat? And is it based on climate, the season? Are they following food? Are they going to breed? Are they going to give birth? Really helps us have a better glimpse into the life of these animals. And that's what all of this, the workup, the science, and studying them is all about. We want to learn more about sharks so that we're able to put better protections in place for them. All right, so now you're going to see the rest of the workup, the data collection process that happens before the tag is placed on or in the shark.
Hi guys, I'm going to lead you down here with scientific workup. So this is how we take, as Jillian mentioned, our data and our scientific measurements and biological samples for each of our sharks. Now, this is pretty much the same process no matter what size shark we're doing. It doesn't matter if it's a tiny little nurse shark or a big tiger shark that we might be working up. The only difference is a little nurse shark we can do in a little blue tub here, and something like a tiger shark we leave in the water and we go out on boats to work it out, and we don't bring it back. Now, everything we do is recorded, so we have data books. So every time we work up a shark, all of the measurements and all the samples we collect get recorded, so we know exactly what measurements we took from that individual shark. So the first thing we would do would be to see if we've caught the shark before. So that tiny pit tag, that tiny microchip, gets implanted into every single one of our sharks. So if we've caught the shark before, the shark will already have that pit tag inserted in the shark. So we're going to have a little scan and see if the shark's got one. First of all, though, we're going to put the shark into this nice trough, which has a tape measure attached to the bottom. This is what we're going to use later on after we've scanned to see if we've caught this shark before, to measure its length. So we're just going to pop it gently on the blue tub. I'm going to get Angie to kind of hold it for me, and we're just going to fill it up with some water. Dan here is going to gently take this little nurse shark, and he's going to place her into the trough and swim her all the way down. So her nose is touching the 0 on the tape measure. Perfect. So as we said, we're going to check with the pit tag reader to see if we've caught this shark before. So I'm just going to scan, and there we go. Beep. We've caught her before, so she has a tag kind of put in here. So the first thing we're going to do now is, we know we've caught the shark before, is we're going to take the length measurements to see how big the shark is. So the first measurement we take is from the top of the shark's nose right to the spot before the tail. This is called the PCL, or the pre-caudal length. So it's just before the tail here. So I'm going to pop my little tool down to the bottom, and this shark is measuring 44.3 centimeters. That's the PCL. And so someone is writing that down in the book for us. The next measurement we would take is the fork length. Now, as Angela mentioned, some sharks have a lower lobe to their tail, so there's a nice fork where the lower lobe meets the top lobe. And their sharks don't have that, so that's not a measurement we take with these guys. But if this was a tiger shark or a lemon shark, the next measurement we take would be that fork length. So the final length measurement we take is the total length. So it's how big that shark is from tip to right to its tail. So this shark is 62.3 centimeters. So pretty good size. So we're not quite done with all of our length measurements. The next measurements we take are width. So we take 3 different width measurements, and the reason is to kind of assess how healthy the shark is, what its body condition is. So I'm just going to slide the second tape measure. Just goes underneath the shark, around its tail at the PCL. So I pinch it around, I pinch the tape measure, and I pull it away. That's 7.7 centimeters. The next one goes just underneath the dorsal fin here, right where there is a little gap from the dorsal fin to the body of the shark. Pinch, pull away, and that's 12.6 centimeters. And the final one, just going to lift the shark up, going to wiggle it all the way underneath Dan's hands, right to here, and pull it away. And Dan's just going to let the little shark have a bit of a swim around now, just to relax a little bit. And that measurement is 23.9 centimeters. So that's the width measurements for the shark. We're just going to put some brand new water in here, just to freshen it up. I'm going to take our next samples. No worries. So the next measurement we're going to take is actually a sample. So we want to see what this, if this was a new shark, we would take something called DNA. And that is basically the genetic makeup of the shark. Now we only take this once from a shark. So this little girl hasn't had this taken before, so we're going to take it today. And the second measurement we take is called isotope sample. So it's basically like taking a tiny little thin clip. We use a very quick little measurement here, some tiny scissors, and it's like clipping your fingernail. So it doesn't hurt the shark at all. It's just like when your mum's clipped your fingernails. And so we take a tiny little thin clip from the dorsal fin, and that's used to analyze its diet, which is pretty cool. So we can see what this shark has been eating kind of over up to a year, which is a pretty cool measurement. Sample, sorry. So Dan's going to pick this little nurse up for me.
Sure.
Yep. Pop her in here. And so I'm going to use this nice and quickly. There we go. Perfect. Well done.
Good morning.
So I'm going to show you guys how small the piece is. If you can see right there, I'll put it on my finger. So it really is just like if you might feel pressure if somebody's pushing on you, right? But you can see how tiny it is. And that's going to be cut into 2 pieces and put in these sample vials and sent off to a lab to look at the diet of the shark and the DNA of the shark. All right, so that is done for sharks all over the world and every shark that the lab catches. And the reason it's done is about 100 million sharks are killed every single year, which is a really big, scary number. And in order to change that, to have it reduced, and to make sure that more species don't become endangered, critically endangered, or extinct, we have to learn about them. The things we mentioned, their habitats, their diets, their migration patterns, in order to put laws in place. It's not enough to just say, we love sharks, let's save them. We want to actually get better laws put in place. And the science is really, really important for that. This data collected in places like the lab. For example, data and studies done by the lab got lemon sharks protected in Florida. It also helped to establish the shark sanctuary here in the Bahamas. It's illegal to catch and kill sharks here. So the scientific data and the work that the lab has been doing since 1990 is a big part of the reason that these animals are protected here. So that's why this information is collected, and that's why it's really, really important to be able to do this and have access to these animals so that we can just learn more about them. All right, so we're going to go through. We'll start with 3 questions from each class and see if we have a little time after that. So we're going to go ahead and we'll start with Miss Dolat's class. If you have 3 questions for us, you want to go ahead, unmute your microphone, and go ahead.
Don't raise your hand here. Yes. Sophie, do you want to answer your question?
Why are sharks
Nice and loud, honey. A little louder.
Why are sharks gray?
Can you hear her? Why are sharks gray?
Well, I mean, all sharks have different coloration, so it's not, depending on the species, they might have different patterns, different spots, different markings. So this nurse shark is kind of like a brownish grayish color, but sometimes there's a lot of variation between the different individuals. So it might have a friend that's slightly paler or slightly more brown. So it really depends on which species you're talking about. There's sharks like the whale shark have these white spots all over their body. So there's a huge variation in the markings and the color of sharks.
Yeah, and some of them use their different color and markings to avoid predators, so it actually camouflages them against their background. So yeah, each species is different.
Great question. All right, do you guys have another one?
Stand up, nice smile.
Do sharks jump out the water?
Do sharks jump out of water?
Live out of water?
Mm-hmm. Jump out of water.
Jump.
Yeah. Some of them we often see different, well, not often, sorry. Sometimes we see sharks breaching out of the water. And we think that could be they're trying to get rid of like little animals on their body called parasites. So sometimes you see different sharks coming out of the water trying to get rid of these parasites. Otherwise, there's species of sharks that actually will ambush out of the water when they're catching their food. Like the white shark in South Africa has been seen often ambushing the marine mammals that they eat. So they'll come from the very bottom and they'll accelerate until they get so fast that they actually come out of the water when they're taking their food. So sometimes you'll see white sharks and other sharks feeding, and that's why they leap out of the water. So yes, they do.
Big question. All right, do you guys have one more?
One more, Landon, go ahead.
Why do sharks have 3 layers of teeth?
Well, they actually have more than that. They have lots of rows. We're gonna grab a jaw for you just so you can see. So when we lose our baby teeth, we get our adult teeth. That's why we have to take good care of them, right? Because that's all we get. But sharks, think about when your tooth gets really wiggly right before it falls out. It's kind of like sharks' teeth. They're not attached the same way ours are. They fall out all the time. But that's okay, because when they fall out, they've got plenty of teeth left to go ahead and replace. So if you can see this is the jaw. Let me see if I can get the camera to focus on it. So you can see there's lots of rows of teeth, all right? So this way and this way, and it's kind of like a conveyor belt. So when that front tooth falls out, another one will move forward, and another one, and another one. And as long as that shark is alive, its body is producing new teeth. Because think about it, sharks don't have hands or tools. They have their mouth and their teeth. That's how they catch their food. That's how they eat it. So the teeth are really, really important. So they have lots of rows and thousands of teeth over their lifetime. Great questions. Thank you so much, guys. All right, we're going to go to Miss Care's class if you have 3 questions for us.
I have a question. Have you ever seen a shark have babies?
I have. I actually got to film a lemon shark giving birth. It's probably one of the coolest things I've ever seen. Some sharks lay egg cases. Lemon sharks actually give birth to live young. The little baby is attached to mom with an umbilical cord, just like we were. So that actually leaves a little shark belly button when the lemon sharks are born. So they have a little kind of belly button scar, and I got to see 10 little baby sharks born. They fight, break off from the umbilical cord, and then they're on their own. There's no parental care with sharks, no matter what species, whether it's live birth or egg cases. Mom and dad do not take care of the babies, but those little sharks can swim, they can hide out, they can hunt, they can take care of themselves. They don't actually need mom and dad, but it's pretty incredible to see a little shark start its life. Great question. Do you guys have another one?
How old can sharks get?
Well, it really depends on the species. So some sharks, like the whale shark, it's presumed that they stay alive until they're around 80 years old. There's a shark called the Greenland shark, which lives in the very depth of the ocean and in the really, really cold water. And they don't move around a lot and use much energy. So because of this, they're able to stay, they're able to live a lot longer. And we think they live to around between 350 and 400 years old. Does anybody know how old the nurse sharks get? Because I'm not sure.
Nurse sharks are about, most of the species we have here in Bimini, from tiger sharks, nurse sharks, lemon sharks, anywhere from 25 to 40 years. They may live longer. That's just as long as, like, scientists know. Like, same thing with the Greenland shark. They live at least that long. They might live longer. One of the cool things about shark science and what the lab has done is there are new discoveries about sharks every single day. All over the world, new species are being discovered every year. So it's really exciting. So a lot of the stuff we know can change or evolve as we have different technology, but especially with the age of sharks, like the lemon shark, they thought they only lived about 25, but the lab figured out that they can actually live a lot closer to about 40 years from research done right here. So pretty fascinating stuff. Great question. You guys have one more?
Yeah. How big do sharks get?
Yeah, sharks range in size a lot. In fact, when you typically think of a shark, you might think of, the big sharks like the great whites or the hammerheads or stuff that can be up to 3 to 4 meters. But in fact, hundreds and hundreds of different species are actually no bigger than 2 to 3 feet in length. In regards to how big sharks can get, the largest shark, the largest fish that actually lives is the whale shark. And I want to say it's 17 meters.
I'm not sure what that is.
It's bigger than a school bus.
Mhm.
Yeah, I'll give you that. It's longer than a school bus.
Very
So
big.
think about that. Some sharks you could hold in your hand, and then some are bigger than a school bus. Okay, great. All right, and then we'll go to Miss Farnell's class. You have 3 questions for us.
Sweetheart. Okay, Emma.
How do you know whether it's safe to swim with the sharks?
Can you say it a little louder?
How do you know whether it's safe to swim with the sharks?
Well, so sharks are wild animals, and they are predators, and they deserve our respect. We've all been able to swim with sharks all over the world, diving, snorkeling, and the way we're able to do that is sharks are actually quite intelligent. They don't just swim around looking for people. You might hear those things. You might hear a lot of bad information about sharks, but we're in the water with them. We're watching their behaviors. We're not grabbing them. We're not riding them. We're not wrestling them. We're giving them their space, just like we would any wild animal. And because of that, if we go down, we sit there, we give them their space, we're able to watch them swim around us, we can observe them, study them, and have a really incredible interaction that's safe not only for the animal, but also for us. But it's really about respecting and giving them their space in order to have these kind of interactions with them. Great question.
How many weeks does it take until the mothers give birth?
It depends. I mean, but I know for nurse sharks, they grow in their mummy's tummy until they're around 6 months old. And they grow inside an egg and then feed off the nutrients. And then when it's ready to be born, it'll be born at around 6 months. But each species is different. So do you have examples?
So for example, the great hammerhead has an 11-month gestation, so it's 11 months for them to grow inside their mum before they're born. So it really depends on the species. It can be anything from kind of a couple of months to even up to 2 years sometimes.
Yeah.
Great question. Do you guys have one more?
About how many sharks have you tagged?
So the lab has tagged over 7,000 sharks since we started in 1990, which is a huge number of sharks. And that's anything from these tiny little nurse sharks to big tiger sharks or to big lemon sharks that we catch out on the water. So over 7,000 sharks have been tagged by that, which is a crazy number.
Great, thank you. We're going to go back to Ms. Dolat's class for one more question.
Where's Carly? You can ask from right there, sweetie.
And sharks eat a person.
A little louder.
And sharks eat a person.
So we're not on the menu for sharks. Sometimes bites happen because remember, sharks don't have hands, they don't have tools, they're not swimming to McDonald's to order a burger, they have their mouth, right? And they actually imagine if you had to go around all day and touch everything to figure out if it was food, right? That's kind of what sharks have to do. They have to feel with their mouths, they'll look, they'll use their other senses, but that last thing, that kind of bite, and a lot of times when they actually bite, their eyes are either rolled back or they have this special eyelid. So bites do happen, very, very rare, but sharks are not eating people, right? People have, they have a bite, it's an injury, but the sharks are not eating people. And you guys have this amazing opportunity to share what you've learned today and talk about how remarkable, important, and interesting sharks are, because you're going to hear a lot of stuff, especially as you get older, about how bad sharks are. They're monsters, they're man-eaters, but now you've learned some really cool facts. Maybe you can study a little bit more and share those facts with your friends, your family, other students at school, because they're not man-eating monsters. They're really, really important, absolutely necessary for healthy oceans, which means they're really necessary for us. Question. All right, let's go to Miss Kara's class for one more question.
How heavy can a shark get?
Can you say that again?
How heavy can a shark get?
Well, I can tell you that nurse sharks get to around 200 to 300 pounds, but how I can compare that to something that you can understand, I don't know. Very heavy.
Yeah. When you think of like great whites and whale sharks, thousands and thousands of pounds. Very big animals. You imagine an animal that's longer than a school bus. Actually, tens of thousands of pounds. So, or tiny little lantern shark in your hand, less than a pound. So again, you've heard us say that a lot. It's different with every shark. So quite a different size range. Great question. All right, and we'll finish with one last one from St. James School.
Have sharks always been the apex predator?
That's a really
That's a
great
good question.
That's a really great question. Actually, sharks aren't always the apex predators. What you might not know is there are some sharks that actually feed lower down in the food chain. There are some fish that are even higher up in the food chain than some sharks. So it's always said that sharks are apex predators. They definitely play a very important role in the marine environment that they're in, but they're not always on the top of the food chain.
Well, thank you so much to the classes for joining us today. Anybody watching, if you guys want to go ahead and unmute your microphones and say goodbye to everybody. Bye.